Hey, APE students, let's do some biodiversity calculations. Excuse me, you should have your packet out so that you can be following along. The purpose of the biodiversity lab is to conduct a tree inventory at School Forest. All of that data has been collected for us, and you have a spreadsheet that's been shared with you, so you can download that spreadsheet and save it in Excel, as we've done before. In addition to calculating richness, Shannon index, and evenness, which are the three biodiversity indices, we'll also calculate the density of trees in school forest and do a graph that shows us the correlation between the height of the tree and the DBH, or diameter breast height. So I have a sample data set here with animals from the African savanna to use to model for you how we're going to calculate richness, Shannon index, and evenness. Richness is is an easy calculation because all I have to do is count up the number of species. So in this case, I add all the different numbers of species together and I get a richness of 10. The Shannon index is a little bit more complex. When you look at the formula initially, that formula looks a little bit complex. So let's break it down. It's actually quite simple. What I'm doing in the Shannon index is I'm going to take and sum together. I'm going to take the opposite of the sum of this value that I calculate for each different species. PI is the relative abundance. So that's simply if I have 3 wildebeest divided by 73 total different organisms in my ecosystem, 3 divided by 73 is a relative abundance of 0.041. I take that relative abundance times the natural log of that value. The natural log on your graphing calculator or scientific calculator is this ln function. And then I multiply those two values together. The relative abundance times the natural log of the relative abundance for the wildebeest is negative 0.131. Remember in our original formula that I'm going to sum all those values together. So I'll do this calculation for all 10 species, add them together. Since I'm adding together negative values, I will take the opposite of that or turn it into a positive value. Here's a sample data table where all of that's been worked out for you. You can go back and look in the packet so that that Shannon index value or H value of 1.7 holds some meaning for you. The last calculation, the evenness, is a pretty straightforward formula. It's H, or the Shannon index, divided by the natural log of richness, or the number of species. So in this case, 1.737 divided by the natural log of 10, since that is how many species I had. You are also going to calculate the density of trees in your formula. This is an example that is in your packet. So the first thing you want to do is go to your, I'm going to go ahead to the next page for a second, looking at the data table. I can take and go down to the bottom of my point to plant distances, and I can do an equals average to get that average point to plant distance. I'm going to square that since we're talking about the area of trees. And so I get the number of trees that I have per meter squared, but because density is number of trees per hectare in this case, we are going to take the reciprocal value of that to get the number of trees per hectare and do a conversion from meters to hectares. The last thing that you're going to do is highlight the height and the diameter breast height, or DBH, columns and insert a chart. The directions tell you to just go to the recommended chart. You're going to insert a scatter plot, and then your lab packet has all of the information for how to get the statistical values that you need to put on the graph so you can turn it in. Good luck. I'll see you in lab.